is solving systems. Remember, a system of equations is two or more equations. So this is, Brandon, put that away. Solving systems by substitution. So I just want to have a little chat about substitution. What do you think when you hear substitution? You're substituting. What do you like? What does it make you think of in life?
A variable for a number.
What? To change. Okay, but forget math. I'm not like forget math. When do you do substitutions? A substitute. Oh, that's a good one. That's not one I had in mind. A substitute teacher, right? You take out your teacher and you put a substitute teacher in its place to fulfill the same role.
To replace.
Okay, to replace. Hopefully of equal value is the goal. Yes.
Okay, so last night we played the game called Bigger and Better, and we substitute things, and we started with a crayon and we got a crock pot.
Oh, nice. I love that game. That game doesn't work for substitution here because what the kind of substitution we're going to do is taking out something and putting in something of equal value, but it is a substitution. You are substituting something. I'm thinking, I think sports. Who plays sports in here?
Me and Coach.
Where do you substitute?
If someone gets you have to like.
You sub a player in if someone's hurt or if someone's tired or if someone's not doing well, right? Okay, so think like this. Who knows basketball in here? A few of you? Okay, let's talk basketball for just a second. Michael, will you put your iPad away? If we're talking basketball, if I said, give me a good point guard.
Me.
Any of you point guards?
Yeah.
You don't play basketball, do you? No, you were on cheer.
In my dreams.
In your dreams. Okay, let's do this. I was a point guard. Okay? So at point guard, my job is dribble the ball up, penetrate and pass off, or, make something happen. If I'm getting winded, my friend Melissa is also a point guard, and she would sub in for me as point guard, right? We are of equal value. I'm a point guard, she's a point guard. That's a substitution. You want them to be of equal value. Now, in the grand scheme of things, either I'm better than Melissa or Melissa's better than me in some way or another, right? But we're thinking of this as equal value, okay? Here's a perfect example of equal value. Who's musical? Some of you play instruments, right? Okay, in the music world, this works beautifully. If you have a half rest somewhere in music, and we take that half rest out, you have to substitute for it something of equal value, something that holds the place of a half rest. So either 2 quarter rests, or 2 quarter notes, or 1 half note, right? Have the same value as that half rest. So in other words, substitution means whatever you take out, you need to put something of equal value back in its place. Does that make sense? Okay, that is substitution. So what we're going to do today is we are going to solve these systems of equations instead of by graphing, because I know you guys love the graphing ones. We're going to be done with graphing, and we're going to solve them instead with substitution. Okay? So here's the deal. First example. You have these 2 equations. Y equals 3x. And I'm going to color code just so you can see where things are falling. And then x plus y equals negative 32. Okay, so 2 equations just like we did with graphing, but now instead of solving it by graphing them, we're going to solve it by using substitution. In order to substitute, there is one word that is huge. Okay, you have to isolate a variable. Sometimes the book's going to do that for you, and sometimes you have to do it. In this case, you have your black equation is y equals 3x, okay? Your blue equation is x plus y equals negative 32. No, you did not just steal one of my Jolly Ranchers without asking me. Unbelievable. No. So if this is your setup, is there a variable that is isolated by itself? The y, right? This one is isolated. This one's by itself, okay? So if you have a variable that's isolated, then you can substitute for that variable. I know right now that y and 3x are of equal value. So if I have a y somewhere, I can take out a y and put in what? A 3x, right? Because y equals 3x, okay? So wherever I see a y, I can put in a 3x. Does that make sense? Y and 3x are equal to each other. So look here, there is a y. I can take out that y, put in a 3x, and now I only have one variable, which means I can solve, okay? So I have right now x plus 3x equals negative 32. Josiah. Okay? X plus 3x equals negative 32. Now here's the deal. We lost our y. That's okay. We're going to get it back later, okay? We just want to simplify this. So what is x plus 3x? 4x. So you're going to say 4x equals negative 32. And now you divide, okay? What? Yeah, what? Oh, my word. You need to stop talking. Stop talking. So x equals negative. Okay, here's the deal, guys. Okay, so we substituted. We got x equals 8. Now, here's the deal. Our answer for these is the same as our answer was with graphing. Bella, I'm up here. X equals and y equals is going to get you a point. Okay, so your answer is either a point, or it's infinitely many, or it's no solution. For today, it's a point. Okay, we're not getting into the infinitely many no solution yet. So your answer should always be an x and a y. You don't need to write that down right now. Okay, I'm just showing you the format. I'll get you the answer in a minute. Okay, so if x equals negative 8, here's the deal. I know what x is. I want to know what y is. If you look back at your original equations, do you see a way that you can figure out what y is if we know x?
By plugging it into the end.
By plugging it in. Okay, so if x equals negative 8, plug it in right here. We know y equals 3x. So we can say y equals 3 times negative 8, which means y equals negative 24. Okay? That means that your answer is this point, negative 8, negative 24. Okay?
Oh, wait,
Questions on that? We're going to do 2 more. So
that's a lot.
Okay, do another one.
we're going to do 2 more.
All right.
All right. Here's the deal. What is that? Okay. You can always check your answer by plugging these back into what you started with. So you could plug the x and the y in for x and y here, or you could plug x and y in for x and y up here and check your answer. Okay, so if I plugged it in, if we go back to this equation, y equals 3x, this is your y, this is your x, so 24 should equal 3 times negative 24 should equal 3 times negative 8, and it does. Okay, so that's how you can check your work. Same thing here. X was negative 8 plus y, which was negative 24, and that should equal negative 32, and it does. Okay? You don't have to show me this part of it. I need to see, I need to see that point. Okay? Okay, second example. Let's say your 2 equations are y equals 2x plus 7 and y equals x minus 1. Okay? What was that big word that I said has to happen every time? Isolate. Okay? You have to isolate a variable. Is one of your variables isolated right now?
No. I mean, yes.
Yes. Which one?
The Y.
The y on both of your equations, right? So both of your y's are isolated, which means you may use either one of those to substitute. Okay? So again, it's up to you how you want to do it. I'm going to say this is my y value that I'm going to substitute into the y value of my other equation. So if y is 2x plus 7, I can take out this y and I can put in a 2x plus 7. So if you rewrite that equation now, it's going to say 2x plus 7 equals what? X minus 1, right? Because y equals x minus 1, and that y that we're going to plug in is a 2x plus 7, okay? So you're taking something out and you're putting something in of equal value. Then you solve it. How do I solve this equation? Remember, we want to get all the x's on one side, everything else on the other, not divide. So you can subtract 7. I would start with the x's. I would take away an x. Not to say that subtracting 7 is wrong. I'm just going to try and I'm going to keep doing it in the format I've always done it for you so I don't confuse you. So this, x minus x is 0. 2x minus x is what? 1x, right? Just x. So right now we have x plus 7 equals negative 1. We're trying to solve for x. What do you do? Take away the 7. So now here's where I would take away the 7. So if you subtract 7, you get 0 here. So x equals, this is a fluke that it's negative 8 twice in a row. That's not on purpose. Okay, so x is negative 8. Now, if you go back to our two original equations, we had y equals 2x plus 7. You don't need to rewrite these. I want you to see them clear without all my scribbles on them. Those were the two equations we started with. Your job now is to find y. So in order to find y, you're going to take that x value and you're going to plug it in. Which one would you like to plug it into?
Y equals 2x plus 7, which would be y equals 2 times negative 8 plus 7.
Right, so if you do it in that one, 2 times negative 8 plus 7, okay, this is y equals negative 16 plus 7, so y equals negative 9. Okay, that means our answer, because remember our answer is always a point, our answer is negative 8, negative 9. Okay, Bella.
Okay, so like when you put that y like after you got the negative 8 or something, you can just choose
In this case, because the y is isolated here and the y is isolated there, it really doesn't matter which one you plug it into. You could plug it into the bottom one, right? If I would have plugged it into the bottom one, I would have plugged it in here because negative 8 minus 1 is just a pretty simple problem. But you can plug it into the top one or the bottom one because it should work out to the same number if you did it correctly in either one of them because your x and your y are going to be the same in either equation. Yeah, Jada.
Okay, the first one makes so much sense. The part where I'm confused about this problem is like the first part where you like where the x's and the y when you like switched it up.
Okay, let's do this. I'm going to give you another one in that same format, just with different numbers. Okay? So if I tell you that y equals x minus 4, and then I tell you y equals 2x plus 7. Okay? Those are your two equations to work with. We know that y and x minus 4 are the same value, right? Because they set them equal to each other. So y, whatever y is, has to be equal to whatever this x minus 4 is. So I can take out the y and put in an x minus 4. Well, if you look at your next equation, here's a y. So take that out. Put in the x minus 4 instead,
Oh.
right?
Okay.
So they're of equal value. If y equals x minus 4, you don't need the y. You can take it out and put in the thing it equals, right? If you take a point guard out, you want to put a point guard back in. Okay? Okay, so if you solve this then, you would subtract x from both sides. So you have negative 4 equals 2x minus x is just x plus 7, okay? And then we would take away the 7. So negative 11 would be your x value.
And then would you plug it back in?
Then you plug it back into whichever equation you would like. I'm just going to plug it into this one, right? That's a negative 11. So we would say y equals negative 11 minus 4. So y is negative 15.
So then that's,
So
it will be
your
negative
answer,
11 and negative 15.
your answer is the point negative 11, negative 15. Okay? Okay, here's where you're going to love me then.
I'm kind of scared.
Yeah. Good. We like intrigued. Let's say we have 3y plus 4x equals 14. And we have negative 2x plus y equals negative 3. You with me? Mm-hmm. What was the big word?
Isolation.
Isolate. Are any of your variables isolated right now?
No.
No. Okay? So this adds a step onto the problem. Your first job is to isolate. Okay? In this problem, you have a 3y, a 4x, a negative 2y, and what here? A 1, essentially, right? If there's ever one that has the 1, that's the one you want to isolate. You don't want to isolate the ones that have the big numbers because it just adds more steps on. So if we want to isolate our y, okay, so we're looking at this equation right now. How do I get y by itself?
By subtracting.
Not subtracting.
You're supposed to add.
You add 2x, right? So if I add 2x here, and I add 2x on this side, this is 0, and I'm left with y equals 2x minus 3, okay? So you have two equations right now. This one, you're going to ignore. We changed it. We rearranged it, okay? Your two equations are here, equation number 1 and equation number 2. Okay, so I'm just going to rewrite them without all the junk in between. So you have 3y plus 4x equals 14. And you have y equals 2x minus 3. Okay, now here's the deal. Question?
I was going to ask, are you going to plug it into a 3 and then parentheses 2x minus 3?
Exactly. Yes. So here's the deal. We are substituting. So we are trying to get rid of the y and put this in its place. So if you look at the green equation, that's going to go right here, right? We know what y is. We're going to take out the y and put what y equals in its place. So it's going to be 3, but because this is an expression, right? It's not just a number this time. It's an expression. We have to put parentheses, and then, here, let's do this so I'm not throwing you off, okay? The 3 is this 3. The y is this, 2x minus 3,
Plus 4x.
right? Because that's what y equals. You follow?
Yeah.
Okay. Then you go back to your equation. Plus 4x equals 14. Okay? So all I did, listen to this. I took out the y, right here, and I put in what y equals, which is 2x minus 3. Okay? Yes?
I get it now.
You do get it. I could see you got it. Okay, let's solve it, and then we'll do another one. If we, oh no, we won't have time. So distribute, okay, you get 6x minus 9 plus 4x equals 14. 6x plus 4x is 10x minus 9 equals 14. Do you guys understand why I don't have a lot of patience when you tell me you didn't understand? Because some of you are screwing around while I'm trying to explain it to you and giggling about silly who knows what's. So I don't have a lot of sympathy when you don't get this. Really. Because you're screwing around. So this becomes 23 divided by 10 is 2.3. Okay? That's your x. How do you find your y? Plug it in. So go back up to where we had y isolated and plug the x in right there. So it's going to be y equals 2 times 2.3 minus 3. Okay? If you do 2 times 2.3, what am I doing? 4.6 minus 3. Okay, so y is 1.6. And that's your y value. So your answer is 2.3, 1.6.
How would you know which x to plug it in at?
You may plug it into either. It's easier if you plug it into the one that's isolated, because then you don't have to move anything around.